Okay. So in any system of equations, our job is to figure out the values for x and y in this case that make the equations true. Now the reason why we waited until now to do this section is because these are very special equations. Part A, first equation, x squared plus y squared equals 25. What is that? What graph is that? It's a circle. X squared minus y squared equals 25 is the graph of an, or a, hyperbola. So what we're going to find is where does a circle intersect a hyperbola, or if it does at all. So that's our job. All right, here it comes. For this one, it is best to use the elimination method. The reason being is because, well, short answer is it's very easy to eliminate variables. For instance, if we just added the equations together, what happens to the y squared terms? They cancel. So if it's going to be easy to eliminate a variable, use elimination. If it's not going to be easy, next two examples, use substitution. All right. So if we add the equations, please do not do bad math. What is x squared plus x squared? 2x squared. Most common mistake, students say x to the fourth. You're adding, you're not multiplying. Y squared's gone. 25 plus 25, 50. So remember in elimination, you multiply one or both equations by a non-zero number so that when you add them, a variable goes away. We didn't have to multiply by anything because we could just add them and y squared went away. Once you get down to one variable, check. You're going to solve for that variable. How are we going to solve for x? Divided by 2. Then what? Take a square root of both sides. 5. Somewhere a unicorn just died. Plus or minus 5. We'll never be able to bring that unicorn back. So sad. Okay, so once you have solved for that variable, go back to one of the original equations and back substitute to find the eliminated variable. I'm going to pick the first one. You could pick the second one, it doesn't matter. So instead of x squared plus y squared equals 25, put 5 in one at a time. So we're going to first do 5, then we'll do negative 5. I squared plus y squared equals 25. 25 plus y squared equals 25. What are we going to get for y? 0. So what ordered pair is that? X comma y. 5, 0. And now we're going to put in negative 5. Well, negative 5 quantity squared is positive 25. So doing the same work, we also get y to be 0. So what ordered pair is that? Good. So this circle of radius 5 and this hyperbola intersect at 2 points, 5, 0, negative 5, 0. So this is different than when we had equations, linear equations. You either had one answer, no answers, or infinitely many answers. Here, you could have one answer, 2 answers, 4 answers, no answers. Right. Part B. Ugh. Terrible. me a second. I wonder if that negative is supposed to be on that 13. Yeah, I guess it can. All right, let's do it to it. So elimination is also preferred here because it's easy to eliminate variables. If, for instance, these were x squareds as they are, and this was an x and a y, then it's not easy to eliminate because it's hard to suddenly make an x squared out of an x. You could do some things, but you have to make some assumptions like you're not multiplying by 0. So if all the powers are the same, you should consider elimination. So what do you want to eliminate, x or y? What? Sure. So we have a negative 5y squared. So this needs to turn into a positive 5y squared. How do we turn it into a positive 5y squared? Multiply everything by 5. So the first equation stays the same. Second equation becomes 5x squared plus 5y squared equals 25. If we add both equations, how many x squareds do we have? Y squareds are gone, equals constant. If 6x squared equals 12, that means x squared equals 2. And that means that x equals plus or minus the square root of 2. Oh my gosh, it's hideous. I know. All right, let's go one at a time. We first start off with x equaling square root of 2. I'm going to put that in for the x in the second equation. So we'll have square root of 2 squared plus y squared equals 5. What is square root of 2 squared? Bring that 2 over to the other side by subtraction. We get y squared equals 3. What does that say about y? Plus or minus square root of 3. So notice that we got these answers when we put in radical 2 in for x. So that means we get the ordered pairs radical 2, radical 3, radical 2, negative radical 3. And now we're going to plug in negative square root of 2. Just like before, but this is not always going to happen, so you do need to do the math for it. Negative radical 2 quantity squared is 2. If I bring that 2 to the other side, I get the equation y squared equals 3. So I'll eventually end up with the exact same y values. So what ordered pairs is this? What's the x value that I plugged in? Comma, positive radical 3, and negative square root of 2, comma, negative radical 3. So we have 4 answers. There's some symmetry going on there. Don't always assume there's going to be symmetry. It really depends on the problem. Types of graphs are they? The first one is a hyperbola. A very, very ugly hyperbola, unfortunately. The second one is another circle. It's a circle of radius square root of 5.